Alright, we're going to talk about two-way frequency tables. Some data sets include categorical data and consist of category labels rather than numbers. A two-way table displays two variable data by organizing it into rows and columns. Constructing a two-way table. Marissa took a survey of 100 pet owners to find out whether cats and dogs preferred being inside or outside during the day. Construct a two-way table for the results. 35 out of 50 cats prefer being inside, 20 out of 50 dogs prefer being inside. Identify the two variables and create the rows and columns for them, then use the information to complete the table. So we've got cats and dogs, and whether they prefer being inside or outside. Our prompt tells us that 35 cats prefer being inside out of 50. This is our total. And we have 20 dogs out of 50 that prefer being inside. When we add up the total amount of cats and dogs, we get that there are 100 total. And so now we can use these totals to figure out how many like being outside and how many total like being inside, how many total like being outside. So we do 50 minus 35, and that gives us 15. And then 50 minus 20 is 30. Once we figure out our total amount of cats and dogs, we can see what is our total for animals that like being inside. That is 35 plus 20, which is 55. And then we have 15 plus 30, which is 45. So we have completed our two-way table. What do the totals or cumulative frequencies allow you to see? Cumulative is everything as a whole. So these cumulative frequencies of using our totals and what the graph gives us allows us to see how many animals prefer being outside. Once we do the cumulative frequencies, we can create a relative frequency chart. Again, we have our cats and dogs and our inside and outside. Cumulative is everything as a whole, but relative frequency is percentages. We're looking at this many cats like being inside out of all the animals that like being inside. So what we're going to do is we have 35 cats out of 55 total that like being inside. To figure this out, we need to divide. When you divide fractions, the top number goes inside the house. So you would have 55 going into 35. When you do that, you have to round, so you have to go 3 places, and then round up to the second place, to your hundredths place. You'll get 636 thousandths, which rounds up to 64 hundredths. And we know that whenever we turn a decimal into a percentage, we just move the decimal to the right 2 places, and that gives us 64%. Now we can do the same thing with dogs. We have 20 out of 55, and when I divide those, I get 36 hundredths, which is 36%. And when I add, this is saying that out of all the animals that like being inside, 64% of those are cats. Out of the animals that like being inside, 36% of those are dogs. So we should add those together, and you should get 100%. We can do the same thing with animals that are outside. For outside, we have 15 cats out of 45 total animals. When we divide that and round to the nearest tenth, we get 33%. We'll do the same thing with dogs, 30 divided by 45, and get 67%. And we can add those together to get 100%. And that is how you create a relative frequency chart. Alright, on the back of that page, information is arranged in 2 rows and columns to display bivariate data. Bivariate is when you have 2 sets of data. The end goal is to compute a relative frequency. How often will that event occur? Look at example 1. Some students were surveyed to find their favorite after-school activity. The results of the survey are shown below. 18 girls and 9 boys said playing sports was their favorite activity. 9 girls and 2 boys said reading was their favorite activity. 13 girls and 9 boys said hanging out with their friends was their favorite activity. Complete the frequency table to show the number of boys and girls who chose each activity. So under sports, that was 9 boys and 18 girls to make a total of 27 children that like playing the sports. For reading, we have 2 boys and 9 girls, which is a total of 11 that enjoy reading. Those that said that hanging out with their friends was their favorite activity, that was 9 boys and 13 girls to make a total of 22 children. And then we have a total of 9 plus 2 plus 9, which is 20 children. And then we have 18 plus 9 plus 13, which gives us 40. So we have a total of 60 kids. And we should be able to add our sports, 27 plus 11 plus 22, to get the 60 as well. So these charts work where you can add vertically or horizontally, and you should be able to get the same answer. So now that we have our frequency, our two-way frequency table created, we are going to flip over to the next page and create a relative frequency chart to figure out how often are these events occurring. Alright, so on page 78 we have part B, complete the relative frequency table to show what percent of each activity choice was chosen by boys and what percent by girls. Round each value to the nearest whole percent. So for boys, we have 9 out of 27. So that's 9 out of 27. When I create this fraction, I can divide it out by saying how many times will 27 go into 9. And of course we have to go 3 places so we can round up to the nearest hundredths. That gives us 33%. We do the same thing for girls, 18 out of 27, which gives us 67%. For reading, we have 2 boys out of 11 boys that like to read. That is 18%. For girls, we have 9 out of 11. That is 82%. And when you get your percentages, you should be able to add them together and say that 18 plus 82 equals 100%. For the sports, 33 plus 67 equals 100%. Now we'll do the same thing for our friends column. We have 9 boys out of 22 total. That gives us 41%. And 13 girls out of 22 girls gives us 59%. And when you add those, you get 100%. Part C, Tim said 18 girls, but only 9 boys enjoy playing sports. Then the girls must be twice as likely to play sports. Do you agree? Explain with ACEs. So you do a lot of races activities, writing prompts in Miss Wright's class. You're going to do something very similar for me, except for with her you have to restate what the question is asking. For this prompt, you can skip that step and go straight on to telling me what it is, how you found the answer, and explaining it. Alright, when we look at this, we have a total of 20 boys and a total of 20 girls. We did not survey the same amount of people, of girls versus boys, So Tim is wrong because Tim cannot say that the girls are twice as likely, considering he did not survey the same amount of boys and girls.
So
Our last page. Our last page is interpreting a two-way table. The two-way table shows results from a survey of dog and cat owners about whether their pet prefers dry food or wet food. Complete the two-way table by finding the cumulative frequencies and the percentages. Does the two-way table show any difference in preference between dogs and cats? So to find the total number of animals that prefer dry food, we add 10 plus 20, which is 30. And to find the total that likes wet food, we add 30 plus 20, which is 50. We surveyed pet owners of 40 cats and pet owners of 40 dogs to have a total of 80. And if you see, our total of dry versus wet also added up to give us 80. So we've completed our two-way table by finding the cumulative frequencies. And then, of course, our percentages would be 10 divided by 30 and 20 divided by 30 for our dry food. When we get 10 divided by 30, that's 33%. So this gives us 67%. 30 divided by 50 gives us 60%, and that leaves us with 40%. The data from, does the two-way table show any difference in preferences between dogs and cats? Explain. Who sees a difference in the preferences?
the cat like the wet food.
All right, so you say that cats like wet food more than they like dry food. 60% of cats like wet food, 33% like dry food. So yes, the cats prefer wet food. Anybody else? Okay.
The dogs will eat either one.
Okay, we got 20-20 on the dogs, so the dogs are like, I don't care, just give me some food. Anybody else? All right, look at example 2. The survey of 7th and 8th graders about their sports preferences is shown. Complete the two-way table with cumulative frequencies and percentages, then describe any relationship you see. So we've got 15 plus 45, which is 60. 15 plus 45, which is 60. We have 30 7th graders, 90 8th graders to give us 120. All right, so we've completed it. We've got for 7th grade, 15 out of 60 is 25%, which gives us 45 out of 60 to give us 75%. And that's the same over here. Who sees a relationship in the data? Mackenzie, what do you see?
They're the same number.
Okay, soccer and basketball have the same amount of 7th graders that play and the same amount of 8th graders that prefer it. Yes, Emma?
7th grade has the same.
Right, 7th grade is the same. Anybody else? Logan?
8th graders play soccer and basketball more.
You have more 8th graders interested in sports than you do 7th graders. And give me one more, Kate.
Okay, 3 times as many people in 8th grade play soccer and basketball than they do in 7th grade, but there's 3 times as many 8th graders as there were in 7th grade.
3 times as many prefer soccer and basketball in 8th grade, but they also have 3 times as many 8th graders than they do 7th graders playing sports. Great job.